Hey, welcome to The Explainer. Today, we're diving into one of the greatest scientific stories ever told. It's really like a multi-generational relay race where one brilliant mind passes the baton of discovery to the next, all to solve a single massive cosmic puzzle. Okay, so let's get right into it. For thousands of years, people looking up at the night sky noticed something really weird. The stars, they move in these nice, predictable arcs. But some of the brightest wandering stars, what we call planets, would occasionally slow down, stop, move backward for a bit, and then continue on their way. So what on earth was going on? This bizarre celestial dance is called retrograde motion. And here's the secret. It's not actually real. It's an illusion. It only happens because we're watching other planets from a moving car, basically. Our planet Earth. As we both orbit the sun at different speeds, it's kind of like when you pass a slower car on the highway. For just a second, it looks like it's going backward. But for ancient astronomers, man, this was a huge problem to solve. To understand their solution, we have to go way back and look at the idea that dominated human thought for over 1,000 years, the geocentric model. For centuries, the prevailing wisdom, really championed by the brilliant astronomer Ptolemy, was simple. And honestly, it was pretty satisfying. Earth is special. We're the center of everything, and everything in the heavens revolves around us. The sun, the moon, the planets, all of it. It makes sense, right? But how do you get that elegant model to explain that wacky backward motion? Ptolemy's solution was, and you have to give him credit, a work of sheer genius. He came up with this system of circles riding on top of other circles. So imagine a planet is moving on a small circle, called an epicycle, and the center of that circle is moving along a much bigger circle around the Earth, the deferent. This creates this cool, looping spiral graph-like path that could perfectly explain that backward motion. And yeah, it sounds complicated because it absolutely was. There were extra off-center points and all sorts of other tweaks, but it had one massive advantage. It worked. For nearly 1,500 years, Ptolemy's system was the gold standard for predicting where you could find the planets in the sky. And, of course, it kept us right where we thought we belonged, at the very center of everything. But then the Renaissance happened, and this new spirit of questioning everything started to bubble up. And that brings us to the first runner in our relay race, the man who dared to suggest a whole new cosmic order, Nicolaus Copernicus. So Copernicus comes along with this radical but beautifully elegant alternative. He basically asked, what if the sun is at the center, not the Earth? Now, he wasn't the very first person to ever think this, but he was the first to build a complete mathematical model around the idea. And here's the truly brilliant part. In Copernicus's model, that weird retrograde motion wasn't a real loop-the-loop anymore. It was just that highway effect I mentioned, an illusion created when a faster-moving Earth overtakes a slower-moving outer planet like Mars. All of a sudden, the most complicated part of the old model became the simplest, most elegant part of the new one. But you have to remember, this was a dangerous idea. Suggesting the Earth moved, that flew in the face of scripture and centuries of philosophy. Fearing the church's wrath, Copernicus just sat on his manuscript for over a decade. He only allowed it to be published as he was literally on his deathbed. And his fears were totally justified. His book was eventually banned by the Vatican for more than 200 years. So Copernicus had planted the seed of revolution, but here's the problem. His model wasn't actually any more accurate than Ptolemy's at predicting where the planets would be. To really test these two ideas against each other, science needed better data, a lot better data. And this brings us to our second runner, the master observer Tycho Brahe. This guy, Tycho Brahe, he was this larger-than-life Danish nobleman who was just obsessed with precision. He got the King of Denmark to fund the most advanced observatory of its time, and he spent decades just mapping the sky. He created a star catalog more accurate than anything that had ever come before. He was an absolute data-gathering machine. But here's the twist. Tycho was a legendary observer, but he wasn't a great mathematician. So as his health started to fail, he hired this brilliant young guy named Johannes Kepler to make sense of his life's work. On his deathbed, Tycho passed the baton, begging Kepler to use his data. But Kepler had other plans. And just like that, the most precise astronomical data in all of human history fell into the hands of the one man on Earth, brilliant enough to figure out what it was all trying to say. Johannes Kepler.
So Kepler gets to work on the toughest problem in the solar system, the orbit of Mars. He spent years trying to fit Tycho's perfect data to a perfect circular orbit. just like Copernicus had assumed. But his best calculations were always off, just by a tiny, nagging amount. 8 minutes of arc. Now that's about the width of a quarter seen from 150 feet away. It's nothing. But Kepler trusted Tycho's data too much to just ignore it. And this moment right here, this is the heart of the scientific method. Kepler was faced with a conflict between a beautiful theory that orbits must be perfect circles and the cold, hard data that said, nope. And he made a brave choice. He threw out the 2,000-year-old belief in perfect circles. He trusted the data, and by doing that, he discovered the true shape of a planet's orbit was an ellipse. This single breakthrough just opened the floodgates. It led to his 3 famous laws of planetary motion, which for the first time didn't just describe what the planets did, but how they did it, with this incredible mathematical precision. The old geocentric model was now officially on life support. But to convince the rest of the world, this revolution needed one last thing: irrefutable, visible proof, a smoking gun. And the final runner in our race, Galileo Galilei, would provide it, thanks to a brand new invention. Now, Galileo didn't invent the telescope, but he was the first to turn a really powerful one to the heavens. And what he saw just shattered the old worldview. He saw moons orbiting Jupiter, proving not everything orbited the Earth. He saw that the moon had mountains and the sun had spots, proving they weren't these perfect, flawless heavenly orbs. But his most damning discovery, the real knockout punch, had to do with Venus. Okay, here's the smoking gun. In Ptolemy's old model, Venus is basically stuck on its track between the Earth and the Sun. So from our point of view, it should only ever look like a crescent, a thin sliver. But what Galileo saw through his telescope was Venus going through a full set of phases, from crescent to nearly full, just like our moon. This was only possible if Venus orbited the Sun. There was no other explanation. Ptolemy's model was officially, demonstrably wrong. But as we all know, proof is not the same thing as acceptance. For his discoveries, Galileo was tried for heresy, forced to publicly deny everything he knew was true, and lived out the rest of his life under house arrest. And get this, it took the Catholic Church an astonishing 359 years, all the way until 1992, to formally admit they were wrong. So this story, this incredible relay race from Copernicus to Tycho to Kepler to Galileo, is just such a powerful reminder that science moves forward by challenging our most cherished assumptions. It makes you wonder, right? What are the perfect circles that we believe in today that are just waiting for a new set of data and a new Kepler to come along and prove them wrong?